Hello, good afternoon, everybody. We're going to try a little video. So I love doing videos on stuff that needs to be, some skill work, some review work, stuff like that. You'll find that I really enjoy talking about where stuff comes from. Hey, we are starting chapter 1. It is quadratics. Hey, I've done quadratics, Mr. Sayers. No need for me. I could take the test today. Well, I think yesterday woke everybody up. Like, there's some things to think about. Very impressed with you as a group. So hopefully that continues. There's a lot going on in this chapter. Quadratic equations is basically what you covered yesterday or last year. Sure, you probably talked about maybe the quadratic formula, stuff like that, maybe a little bit of graphing. We're going to just take it up a notch. And that's what you'll find in mathematics. We'll do some quadratics this year. In calculus, you really start to use calculus, and then you see the power. Unbelievable. You get really good at quadratics, and you can factor them, you can figure out how to work them, and then you use those skills for everything else. Cubics, quartics, quintics, fifth degree polynomials. Little sidebar on fifth degree polynomials. My favorite mathematician, a guy named Everest Galois, proved that you just can't solve a fifth degree polynomial. Like the quadratic formula, you're going to get 1,000 questions. Solve the quadratic, solve the quadratic. But Everest Galois actually proved in the 1700s you can't even think about doing a fifth degree. And in doing so, he created a whole different type of mathematics called abstract math. This is how we do the Rubik's Cube. And this is how we do like chemistry, molecules, and orientations and symmetries. So amazing. So what I'm saying here is get the quadratics down, and you might have a little bit of a glimpse of how all this works out. Pretty cool, pretty cool. Hey, real quick, little background. From Algebra 2, what are there 4 ways to solve a quadratic equation? 4 different methods. It's kind of like, all right, I'm going to learn one way to cook. And if that's the only way you cook, that's great. But if you have 4 different ways, you kind of look at your ingredients, you kind of pick the best. It's the same thing. We gotta dish up the best thing we can. So those 4, we have them all typed up for you, are right here. People come up with different names, and I don't care if you called them factorize with an S or not. Completing the square certainly is a really cool technology. Technology. Why do we even mess around? Have you met my friend Desmos? Unbelievable. Trust me, we live in that day and age. We're not going to mess around with factorizing all the time, but it's like knowing your multiplication tables. 3 times 2 is 6, and it's you kind of need to know that. You need to know how to factor a little bit. You don't have to factor everything, but you need to know it exists. And then, of course, the quadratic formula. Oh, let's take a moment. Okay. All right. Not worthy. All right, factorization. First of all, I will tell you that some people are really good at factorizing quadratics, and some people aren't that good. Here's the key. I can hold you accountable and make you be able to factor everything. If you have a good idea, that is fine with me. If you know what you're after, but you just can't quite see it, that is fine with me, because we have other tools that will do it. But please, be in the ball game. Understand what people are doing. I'm not going to go over the techniques like the X and the bar and the box and the throw the dice, whatever. I've heard many different techniques. I use my number sense, and so I'm just going to walk through maybe 1 or 2 examples. If you can follow through, great. I'll give you a few practice problems, but remember, it's not a foolproof method. It doesn't work every time. All right. Step 1. The first step says get everything to 0. Not necessarily true, but if you want a step-by-step process, let's go with it. That's a fair one. As soon as you get better, then you kind of go, oh, yeah, maybe this is a good time to do that. But fully factorize the other side. This is the art. This is where you as a student either really see the numbers and how they work or not. So I just don't want you to stress out if you don't see it. The reason you factor is because then you'll have two things multiplied equal to 0. And once you have those two things multiplied equal to 0, then you set this equal to 0 and this equal to 0. Okay? You don't see it as AB. You see it as x minus 1 and x minus 2. So those are the two ideas. Sorry, that's pretty small. And then you go ahead and solve those linear equations. All right, here's two great examples for you. Let's look at the first one. Oh, look at that. All right. These are the easiest, but sometimes the hardest, because you're like, there's no number. How am I going to factor that? Well, when we say factor, we're saying try to make it something times something. If you see a common number or a common variable in all the terms, factor that out. So I see an x in here and an x in here, so I'll write that as x. If I factor out an x, I'm basically dividing each one by x. So if I divide this by x, I'm left with 3x. Divide that by x, and I get... All right, those of you who want to get paid a lot of money will say, I think I will use the null factor law. Other people say, oh, I'll just separate these into two equations, and I'll solve each one. That was hard. And because we're in Precalc, I'm going to do these things in 2 steps. So in my mind, I subtracted 5, and then I divided by 3. So I get negative 5/3. Those are the solutions to that quadratic. Graphically, that's where it crosses the x-axis. So, very good. All right, let's go over this bad boy. All right, step 1, get it all equal to 0. I prefer a positive x squared term, so I get to the side where that's positive. So I am going to subtract 5x, subtract 6 from both sides. Now, I have to factorize it. So I don't see anything common in all the terms, so I can't pull out a 2 or anything like that. So this is where this starts to set up. In my mind, I'm going to try to do something times something. Well, this and this have to multiply to x squared. That's a slam dunk. Now, I need this and this to be two numbers that multiply to negative 6. Multiply to negative 6. Multiply to negative 6. Maybe 2 and negative 3. That's pretty cool. Very, if I put a 2 and negative 3, they definitely multiply to negative 6. But does a 2 and a negative 3 combine to a negative 5? I am not sure about that. So I am not going to go with that. What about a negative 6 and a positive 1? So do you see, can you please close the door? Can you see that that's where the number sense comes in? Do you see how they combine? And sure enough, when they multiply, you get negative 6. When you combine them, you get negative 5. I'm going to set these separate, and I get my 2 solutions. Hey, you're awesome. If you try that, and some days you're going to get it, some days you're not, just keep trying. Just keep trying, that's what I have to say. All right. Okay. Let's try a couple more examples. Let's do this one. We've got it all equal to 0. So my thinking here is, I tried to write all this out for you because sometimes it's important just to see the way they think. So the way I think this is two things. It's either going to be 4x times x or 2x times 2x. All right. I'm a little nervous. I see that this positive 1 and this negative, the only thing that really is going to make sense, if this is going to be easy, if it's going to be a -1 and a -1, because those two multiply to positive 1. Well, now I have to think about which one works. Which one of these will end up combining so that I will get the negative 4x? And that's where you have to kind of know, you have to multiply these things out over and over again until you see it. So bottom line is, here I would get a negative 4x and a negative x. So this is kind of a negative 5x. And here I'd get a negative 2x and a negative 2x. So I get a negative 4x. So I'm going to say that this is the winner. And get a little excited. So boo, yay. And then you're off to the races. You're good to go. That's all there is to it. Of course, we'd satisfy that. Do you have to do both the same? No, they're the same one. Just do one of them, get your answer, call it good. For kicks and giggles, you might see this. They are called a double root, a multiplicity of 2. You might now know that the parabola is tangent to the x-axis at x equal to 1/2. These are the little things that you start to connect. Life is good. And we'll get there, but why not throw that out? Hey, this other side. Let's look at this bad boy. 6x squared, 11x plus 10. I'm going to rewrite it like that. Now, there is a lot of possibilities here. So this is where those people that are really into factoring have the little x method, and they're fun to sit next to you because they kind of just tell you the answer. They're awesome. Never give up on them because, and man, if you're good at this, I love it. For me, I like the puzzle. I got some things that multiply to 6, some things that multiply to 10. This is kind of my thought. I'm going to multiply 2 things to get 0. For 6, I kind of labeled those things, and negative 10, I kind of did this. I didn't include the negative because I can kind of put that where I need it. So the question now is, how do these work together to get that negative 11? That negative 11. So in my mind, 6 times 10 is 60. That's way too much. That's I don't see that working. What about the 3 and the 6 and 10? No. How about 3 and 15? So a 3 and 5 is 15. A 2 and a 2 is a 4. A 15 and a 4. Does that make a kind of work? So that's how I think about it. That's just because that's all I've done. That's how I was taught in Algebra 2 in Poudre High School, is we just did 1,000 of these things. So I noticed that connection. I'm pulling the 2x and the 3x. I notice I like the 2 and the 5. Placement's important. I want the 3 and the 5 to multiply. I want the 2 and the 2 to multiply. And then finally I pick my signs. Hey, if you get this, you're good. But trust me, on a problem like this, I think technology, I think quadratic formula is a better route. It's automatic. As long as you believe where it came from, then I think that's the way to go. So you'll get some practice tonight. I want you to always keep those skills going. So that's why we're going to do that. Hey, don't be scared if a problem doesn't look like it's supposed to. So here's the problem. There's no x squared there, Mr. Sayre. It must be in the wrong situation. Well, if you got a fraction, then we can cross multiply. So I'm going to multiply this x over here and this 1 minus x over here, and that's kind of what I end up with. And lo and behold, you're not going to believe it, we get a quadratic. Okay, get everything equal to 0, and once again you're off to the races. Okay, we have other things to do today, so I am going to, if you can factor that, that's great. I believe it is x minus 3. Yep, perfect square. All right, so we're walking through the woods, and we see problems that look a little different. All right. So there's a couple things. I will tell you right now, people are not going to be paying attention. They're going to multiply all this out and get a quadratic. And guess what? It'll work. They'll figure it out somehow. But if you get a quantity squared by itself, then leave it alone. Because we know that all we have to do is take the square root of both sides. That's it. So do not make this difficult. So what we're going to do is we're going to take the positive or negative square root of both sides. Over here I get x plus 2, and over here I get the square root of 7. Well, I can use my calculator if I want, but why? Just leave it as square root of 7. Oopsie. And subtract 2. There are two values there. There's negative 2 plus the square root of 7, and there's negative 2 minus the square root of 7. They're both exact. They're totally correct. If you use your quadratic formula program, you're going to get the decimal equivalents. That's fine. But this is where you're getting paid top dollar for exact solutions. You're getting paid a lot for finding the solutions, but top dollar if you want to do that. Let's try this second one. If you square any number, how are you going to get a negative? So don't get suckered into this without thinking. Take a moment, lean back, kind of look at it. Does that make sense? It doesn't make sense. So you could easily say no answer, but it's not quite right. There's no real solution. There's no real number that will make this work. But if you follow the steps, you can still take the square root of both sides. You probably were introduced to complex numbers a little bit last year. I is equal to the square root of negative 1, so we could rewrite it like that. 1 plus or minus square root of 5, I. So it does have numbers that you can plug into this equation and make it work. They just happen to be complex. Oh, that's where the Mandelbrot set comes, where that weird looking beetle and those colors. There's so much application of complex numbers. Love it. Okay, sorry. Moral of the story. Where are we right now in our life of quadratics? I want you to be able to try to factor. Great. I want you to know if you get it in the form of x plus p squared equal to q, I want you to know that that is an easy thing to solve. All right? So the question might be, or our goal, is how do you take a quadratic and rewrite it like that? Notice a, b, and c are any numbers. I don't use a, b, and c here because they may or may not change. So p and q come from a, b, and c. So my goal here is to tell you how to do that, but I have such a better way of showing why it works. We'll do that tomorrow. All right, this is called completing the square. Tomorrow I'll show you why this works. I'm going to give you the formula, but tomorrow you gotta believe it with your heart and soul because it is way cool. All right, here's the steps. I can do the steps algebraically here, but I'll follow along with an example so you can kind of see it in action. First of all, let's set it equal to 0. Bada boom. We're going to divide both sides by a. Okay. So I'm going to divide everything by a. Here, the 3 is the a value, so I'm going to divide everything by 3. So obviously that goes to 1. 24 divided by 8 is 3, and negative 1 divided by 3 is negative 1/3. Nicely done. I'm going to get the x's alone. What x's alone? This is, you'll see it many different ways in the books. That's fine. All I'm doing is getting everything with an x on this side and all the numbers on the other. Okay, so I'm just going to subtract off the c over a. Well, I don't see a c over here. I see a negative 1/3. So I'm just going to get that on the other side by adding 1/3. All right. This next step is called completing the square. You're going to add something to both sides. It's a teeter-totter, right? If I add 5 bricks to this side, I add 5 bricks to this side. Everything stays the same. We're all in balance. Life is good. So I can do what I want. I'm going to add a number, and then this little 2 is different. So I'm basically taking this number, I'm dividing it by 2 and squaring it. I'll say that again. I'm taking this number, dividing it by 2 and squaring it. I'm adding that to both sides. All right, let's see how that looks. So this is what I added to this side, and this is what I added on this one. Now notice I've added on both sides. So keep things legit. What I've done is I've completed the square. I've written a trinomial that can now be written as a perfect square. Let's see this in action. Let's see if that really we buy that. So this is hard to see, and that's why I like to do it with a numerical example, but x squared plus b over ax plus b over 2a quantity squared can be written as x plus b over 2a quantity squared. If you don't believe me, multiply this all out. You will get this. Exactly. It's way cool. So what does that mean for us over here? If you multiply this out, you get 16, and that makes a lot of sense. It's half of that number squared. You don't have to write it all weird like this. You can take half of that number, 4, square it, 16. So you're going to add 16 both sides. This is a perfect square. X plus 4. Ooh, Mr. Sayers, what's the pattern? Well, this number right here is found by either taking half of that or the square root of that. I would work with this number. It's always going to be half of that number. It's always going to be half of that number. And 16.3 repeating if you want, or 16 1/3 over this side. Well, what do we have? We have a problem that looks exactly like the problems that we just did. I would take plus or minus square root of both sides. I'd call it good. That's all there is to it. Mr. Sayers, I need another example. All right, let's do another example. All right. Can we factor it? 2, 3, 1. I don't think so. Oh, you might as well try in your mind. All right, first thing, I want to divide everything by a 2. Nicely done, Mr. Sayers. No calculator needed. I'm going to complete the square now. I'm going to write this. I like to do this sometimes to be all dramatic. So I'm going to add something to both sides, and I'm going to make this a perfect square. Whew. So the process is half of this number squared. Half of this number squared. So if you want to be like, make all the money in the world, you write it like that. Half of that number squared. But sometimes you do it in your head because you're kind of cool. Over here, you add the same thing. Negative times negative is positive, so that's definitely going to be positive. Half of 5 is 2.5, right? 2.5 squared is, I think, 6.25, but maybe I don't know. So guess what? I can write this like this. That's fine. There's nothing wrong with that. Maybe keep that negative in there just to show that I didn't lose that. And then this is going to be negative 1.5 plus 6.25. That's going to be a number. Don't care. Now the key is that this is now a perfect square, and it is x half of this minus 2.5 squared is equal to, oh, what is that, 4.75? Sorry if I made a mistake there. I think that's right. Hey, now we got it in the mode where we can solve this pretty easily. I'm going to take the square root of both sides. I'm going to add that. Bam! I always like to celebrate just a little bit. I mean, you've worked hard. And there you go. Hey, your homework is going to be 1A.1 and 1A.2. Some of you guys are going to fly through it. Some of you guys are going to, man, I get this one, but not that one. The whole goal is to get rolling on this. I have all the homeworks done. I do them all every year. So it took me a little bit. I was having fun, but I kind of felt the rhythm afterwards. So I think it's a good assignment. All right. Thank you. And we will see you soon. If I can turn it off.